Hey folks, welcome back to another video. Today we are looking at question 1209. Remove all adjacent duplicates in string 2. The way we'll be solving this problem is by using two arrays to help us. One array is a character array that we will be using as a stack. And the other array will be the count array to keep a track of how many times we have seen these adjacent letters if we do have them. So let's jump right in. The first character array, let's just call it stack since we are using it like a stack, and we'll convert the string to a char array. The next thing you need is a count array. For that you need the length of the string, gth, yeah, and then let's just call it count of size n, and then the next thing you need is the current index that you're looking at. The current index will keep a track of the index that we are interested in the stack area. This will become obvious in a second. Let's jump right in. The first thing we need to do is we have a for loop that goes through all of the characters in the string. So we'll increment I with every single iteration. We shall also increment the current index with every iteration. Right. So since current index will actually look at the letters that we care about so far and the ones that we have already removed. So the first thing that you'll do is the character that at current index, it will be reassigned to the one that is at space I. And once that is assigned, the thing that you need to do is you need to update the count. So you'll check, hey, the count of current index, that will be equal to something, but it's based on two conditions first. The first thing is that if current index, if it is greater than 0, and if stack of current index minus 1, that means that the index that we're currently at, if you go just one step back, if it is equal to the one that we just added, that means the count would become current index minus 1, and you'll add 1 to that. So what you're basically checking is that, hey, the character that we just added, is it the same character that we've seen previously? If yes, increment the count. If not, just keep that as 1. And once you've incremented the count array, you need to check, hey, the current index of the count array, is it equal to k? If it is equal to k, we just need to go back k places. So because we're just removing them, removing all of those characters, since it's not really a stack, but a character array that's adding a stack, you can't really pop everything, but you can definitely move the current index that you're looking at by k steps. So you will decrement current index by k. So that's the reason why we have the step right here. So a stack of current index is equal to stack of I, because this current index is where we're actually keeping a track of the letters that we see and how we care about them. But I is literally looking at all of the letters in the string. Right. Once the stack, once you've gone through all of the letters in the string, you just need to return the stack that you have as a string, but you would need to return it from 0 index to the current index, because that is where you will get the resultant string. So let's quickly compile this and see if it's okay. Why is that? Oh, it's I. Right. The first test case is okay. Everything else is okay as well. Awesome. I know this is a little hard to explain as a solution, but if you write it down and go through an example, it becomes a lot easier. So I highly recommend you do that. So let's talk about the space and the time complexity. The time complexity of the entire solution is O of n, since we are going through every single letter in the string that's provided to us. And then the space complexity is also O of n, since we are using the character array and the count array. Perfect. If you have any questions, please let me know in the comments below. And please don't forget to subscribe. I would really appreciate that. And see you all in the next video. Peace.